Example number 2. Find the area of the region enclosed by the graphs of the given functions and the vertical lines x equals a and x equals b. So these are going to represent our limits of integration once again. So let's look at 2a. We're given the function f of x and the function g of x. Our first step is to put both of these in our calculator to determine which graph is greater than the other, because we have to make sure we put that first into our definite integral we're about ready to set up. So let's take a look. I'm going to go ahead and enter in those two functions in example 2a. This is going to be what? The square root of x. And the next function was negative 1/2 times x minus 1. Hope you can see that okay, folks. Hit enter, hit graph. So that's radical x being graphed now, and this is, of course, the linear function g. So do you notice that from 1 to 4, clearly the graph of radical x is greater than the graph of negative 1/2 x minus 1. So we're going to put radical x first and then subtract off this negative 1/2 x minus 1 when we set up our integral. Let's go ahead and do that now. So based upon the graphs we just saw, we would set up this interval, or excuse me, this definite integral. So the area bounded between the graphs of these two functions over the closed interval a to b would be expressed this way. Lower limit of integration is 1. Upper limit of integration is 4. Now we will put radical x first, because again, the graph of that function was above the graph of this function. So the graph that was below goes second, and it will look like this. And there is our setup. This time we would rewrite this radical x as what? As x to the 1/2. And then we would distribute this negative through. So a negative times a negative is a positive. Positive 1/2 x. Again, a negative times a negative is a positive 1. And it's all with respect to x. Okay, so let's go ahead and come up with the value of this definite integral. So the first thing is to integrate this expression. That would give us what? That would give us, x to the 1 plus 1/2 is what? 3/2. And remember, when you divide by 3/2, it's the same as multiplying by the reciprocal, which is 2/3. And then we're going to add what? Well, x to the first understood here gives us x squared. When we divide by the 2, you're going to be multiplying it by a 2 that's already there, right? So again, I'm adding 1 to this 1, give me a 2. I divide by the new exponent 2, but because there's already a 2 here, 2 times 2 is 4. Very good. And then this 1 becomes a what? The antiderivative or the integral of a constant is always the constant times x. Okay. So what we have to do now is fill in the numbers. All right, so the first part, upper limit of integration. We get this. 2 times the quantity, 4 to the 3/2, all over 3, plus what? 4 squared over 4, plus 4. There's your upper limit value, minus our lower limit, which is just replacing every x with a 1. All right, let's go ahead and do that. All right, so all we have to do now is take out our calculator and then subtract whatever we get here with the calculator, and we get our answer. So if I calculated this correctly, I got 137/12 units squared. Okay, pretty sure that's correct. Check my work if you like. That completes example 2, letter A. Let's look at 2B next. All right, example 2B, same directions as we just saw in example 2A. What we have to do first is what? We have to determine which of these graphs is above the other. So we'll go ahead and do that using our calculator. All right, so our first function was just f of x equaling x. And our second function was g of x equaling e to the x. So let's see what those look like graphically. There is the graph of x right now. And here comes the graph of, e to the x. So hopefully you can see from 1 to 3, clearly the graph that's red, which is representing e to the x, is above, is greater than the function in blue, which is f of x. So don't get so caught up with, f of x has to be first, g of x has to be first. Just know that whatever function graphically is above the other one, know that this has to go first in the integral. The one above has to go first in the integral. All right, so let's set it up. So again, based upon what we just saw, our definite integral will look like what? Well, first of all, let's put our limits of integration on here. Lower limit's a, upper limit is b, and then what graph was above the other one? Which one was greater? This one was greater. So you put that one first. And you're going to subtract off the graph that was below the other one, which was x. All right. So now we have our definite integral set up. All we have to do at this point is evaluate it. So what do we get? Well, the integral of e to the x is e to the x. All right. The integral of x is x to the 1 plus 1 or 2 divided by a deuce. And we're going to look at evaluating this based upon these limits of integration. Okay, so what do we get? Well, we get what? E cubed minus 3 squared over 2. Okay. Minus what quantity? Minus, well, now replace every x with the lower limit of integration, which is a 1. So, oh, geez, I can't draw 2. I still can't do that. I'm taking medication for it. It's not really working. I know you're so excited to hear that again and again and again. I got to come up with some more material. Anyway, what do we come up with here? Area equals what? Well, we get e cubed. Let's just leave it like that for now. E cubed, then what? Minus 9 halves. And then distribute the negative. So minus e, and then a negative times a negative is a what? Correct, a positive. 1 squared is 1, all over 2. So if you were to keep this in exact value, the exact value of this definite integral, which is the area that's bounded, the area that's it's creating, I've just completely lost what I was going to say. This is so embarrassing. Jeez. Oh, here's what I was going to say. The actual exact area that is being bounded between the graphs of these two functions over the closed interval from 1 to 3 is going to be what? E cubed minus e, and then whatever this is, negative 9 halves plus 1 half. That is negative 8 halves or minus 4. This is exact, folks. This is the exact area. Okay? If you were asked to approximate it, you would get approximately, I believe, this. All right. That's a U, by the way. Okay? I love making videos and posting them on YouTube. Yippee! That completes example 2B. Let's move on to a little bit different type in example 3. Coming up.